In this video, we're going to introduce what a function is. But first, I want to do a brief overview of what we have gone over this semester as it leads directly up to our new definition of a function. The first thing we learned how to do was, we reviewed, was how to simplify expressions, and we used PEMDAS to help us with that process. You can recall that our P means we solve inside our parentheses first, and 2 plus 3 is 5. Everything else remains the same. My E tells me that I'm going to do my exponent next, which means I'm going to take 5 times itself. And I'm left with 4 times 25, which gives me 100. Right, after we reviewed how to simplify expressions, we moved on to equations. All right, so we inserted an equal sign, we put in a variable, and we had ourselves an equation. So here I have 2x plus 4 equals 16. And then we used inverse operations to solve. All right, recall that we always get rid of our constant first. So I'm going to subtract 4 from both sides of my equal sign. When I do that, I'm left with 2x equals 12. And my last step then is to divide by my coefficient, 2, on both sides, which leaves me with x equals 6. We need to ask ourselves, though, what happens if we have two variables? What happens if we have two variables? So let's go ahead and look at an example. In this example, I'm going to use the equation y equals 4x minus 3. So I have a y and an x. And I'm going to say that I'm going to make x equal to 1. And my question is, what happens to y when I do that? Well, if I plug 1 into my equation, I end up with y equals 4 times 1 minus 3. And I can go ahead and start simplifying that. Y is equal to 4 minus 3, because 4 times 1 is 4. And 4 minus 3 leaves me with y equals 1. So if x equals 1, then y equals 1. And I can do it again. This time I am going to say that I'm going to make x equal to 2. So I'm going to take y equals 4 times 2. I'm going to subtract 3 from that. That simplifies to y equals 8 minus 3. And when I subtract 3 from 8, I end up with y equals 5. So if x is 2, y is 5. And I can keep doing this. I can keep picking numbers and plugging them in. But what I see is I end up with these sets of numbers. X equals 1, y equals 1 goes together. X equals 2, y equals 5 goes together. X equals 3, y equals 9 goes together. All right, these pairs are what create what we call a relation. A relation pairs inputs with outputs. Inputs are going to be your x values and outputs are going to be your y values. Great. But what does that actually look like? What can we expect to see when it comes to relation? Well, there are actually several different forms of a relation. There are equations, like we just saw. So here I am going to write y equals 2x plus 3. There are also input and output tables. So here I show that when I choose an x value, 0, 1, 2, or 3, I get a y value of 3, 5, 7, and 9. Another way we can represent this is by mapping. And then we can also use a graph to represent a relation. All 4 of these represent the same exact relation. They're just in 4 different representations. Let's talk about a special kind of relation, which brings us to the star of our show, a function. A function is a special type of relation. A relation becomes a function when each input has exactly one output. A simpler way to remember this is that x's never repeat themselves. So what I'm going to do to help explain this or show this is to use an example and a counterexample. So on the left side of my notes here, I'm going to give you just basic examples of relations. And then on the right side, I'm going to give you examples of what a function looks like. Okay, so to start, I'm just going to show us some ordered pairs. All right, and on the right column, or on the left column under relation, I can see right away that I have these repeating ones here. All right, x's cannot repeat. Y's can, but x's can't. So because we have 1 in the x column 2 times, that makes it a relation. Whereas here, I see that each of these is a unique value. Okay, so what I've done here is I've mapped out these 3 coordinate points. All right, I don't have to draw them more than once. So here I have 1 and 1. I just put 1 on this left side the one time. And then the only other x value is 2. Right, on the right side I had 1, 2, and 3 because that represents all of my y values. And I can visually see that this is a relation, not a function, because I have 2 lines stemming from the x side. X will always be on the left and y's will always be on the right, just like with our coordinate points. And because this x is repeating, and it never can, to be a function, this is not a function. Once again here, I just wrote out each of my x values in the left and my y values in the right. I see that my x only corresponded to one y value every single time. There were no repeating x values, therefore this is a function. Okay, another way we can represent this or see this, visualize this, is on a graph. All right, so I have my x-axis on the bottom and my y-axis going up. My first coordinate point was 1, 1. So I put a point for x at 1 and y at 1. That left me here. I have a point where x is 1 and y is 2 here. And one where x is 2 and y is 3. So I plotted those 3 points. Let's look at what a function's graph will look like. Okay, everything here looks almost the exact same. I have my 3 points. What I want to draw your attention to, though, on the relation side, is that 2 points are stacked directly on top of each other. So if I drew a vertical line through them, it would cross both of them. That is what we call the vertical line test. And if you can ever draw a line straight up and down through the same 2 points, then that means that you do not have a function. All right, so these are 3 visual representations, 3 comparisons of what constitutes a relation versus the special function. Again, the one thing you want to look for is, are your x's repeating? If your x does not repeat, then you have a function. Otherwise, it's just a plain old relation.